So we talked about these. Like I said, we talked about some of these yesterday. And we may have gotten through all of them, but I want to record a quick recap so that you have a quick reference to go to if you get stuck while you're working on whether it's you get more math points or the quiz, the requiz or follow-up, whatever it's called. Okay, so on here, when that, if you're given the equation and not the graph, then go use Desmos and graph it, okay? Graph it so you can visually see it so that you can see what the y values are. Okay, so the y values for this one don't go below this line right here where it levels off. Okay, and it levels off at +1. So your range is y is greater than +1. Okay, so that would have been your answer for this one. Okay. Would y'all close the door too? I know my voice carries down the hallway. That door's open. Okay. For this second one, okay, it was asking you to look at the equation, and this is what we did on Monday, right? So it gave you the equation in exponential form, and you had to be able to answer the questions based on the equation. So this number out front is your initial amount or your starting amount. So 3 of your choices are asking about that number. Okay, the initial amount should say 620. This one says 40, so that's not right. This one says 140, and that one says 60. So none of those are correct. So by default, it should be B. Okay, but we can double check. Okay, so right here, this is what tells it if it increases or decreases. That's the rate that it changes. If that number is less than 1, it's going to decrease. So that's correct. Okay. So the other thing is this 40 number. So you may not have realized that that is the correct answer. But remember, when we're talking about percentages, you have to start with that 100%. Okay, and subtract whatever whatever amount that you're decreasing by to get this number in here. So if we had been trying to come up with this equation, we would have taken 100 minus 40 and got the 60, and that's where that number in there came from. Okay, but when you're working it backwards, you can still take what's in that parentheses there and subtract it from 100 and figure out what was subtracted originally to get that. So that's where the 40% came from, because it's decreasing by 40% every time because you're only getting 60% of it when you multiply by it. If it were increasing, that number would have been 1 point something, and you would have subtracted 100 from that to get back to whatever it's increasing by. Yes.
The 60, you got it from the 0.6, is that what you?
Yes. Okay. Because this is the decimal form of a percentage.
Right. Okay.
Yes. So in the next one here, okay, we talked about this one, that you have to figure out what the pattern is. So for you guys, y'all had a multiplying pattern. It was multiplying by 2 every time. Okay, so a multiplying pattern means that it's exponential. Can't spell. Anyway, it's exponential because it's multiplying. So f of x, because that's what we're given in the table. We're not given y, we're given f of x, so we have to use that as our variable that we're using. Okay, so f of x equals, and then it's my starting amount, which is always my y-intercept. Your starting amount is your y-intercept, whether it's linear. Your starting amount is your y-intercept, whether it's quadratic. Your starting amount is your y-intercept. If it's exponential, it doesn't matter. For all of those functions, your starting amount is your y-intercept. Those are the same things. Okay, so your y-intercept is -3, so that's where you're going to start your exponential function. Okay, the pattern is multiplying by 2. So the pattern is times 2, and it gets paired with the exponent of x because that's my pattern. If that my pattern, okay, had have been adding by 2, okay, so if the pattern was adding by 2 every time, then that would make it linear. And a linear function would still start out with f of x equals, but my pattern of 2 still gets paired with the x. It just is multiplied instead of an exponent. Okay, so exponential, the pattern is paired with an exponent of x. For a linear, it's just in line, right? It's in the same line, 2x. My starting point would still be -3, so we'd put -3 or plus -3, right? So, but we don't like to put a plus negative, so I'm going to rewrite it as just -3 because that's still my starting point. It's still my y-intercept, okay, when it's linear. So make sure that you can identify whether it's linear or whether it's exponential to know how to write the function. You have to be able to determine whether it's one or the other when you're given the table, and that's done by the pattern. So on problem number 4 of the quiz, okay, problem number 4 of the quiz, it asked you for what the y-intercept represents. Tells you about the situation. Okay? So in this case, the y-intercept was 4. Okay? If you count it, 1, 2, 3, 4, right? It's 4 thousands is what it represents. Okay? And it represents that the farmer had 4,000 bushels of wheat before they started using the new fertilizer. So this one we talked about looked close, okay, but it says that before they bought their farm or collected the year they bought their farm, and is that what it's asking up here? How many was it when they bought their farm? Or they started using new fertilizer. So you just had to pay attention to the wording on that one because both of them look like they could be correct, but you have to pay attention to how it reads. Okay. The next one is asking for the asymptote. Okay. For right now, in this class, you will never, ever, ever, ever have a vertical asymptote. The only asymptotes that we deal with in this class are horizontal ones. So if your line is going up and down and it's asking for the asymptote, then it is not correct. It's false. Okay, you will deal with vertical asymptotes in higher level math classes, but you do not in Algebra 1. Okay, so never pick the vertical line when it's talking about the asymptote. Okay, it will always be the line that butts up against where that your equation or your function levels off, okay, where it starts creating that line, okay, that looks like it merges together. Okay, that's your asymptote. So in this case, the asymptote would have been y equals 5 if you had been asked to tell what the asymptote was. Oops. Okay, so simplifying the square root. It does not want the decimal. We talked about that yesterday. It doesn't want the decimal of it. It wants it in the simplest accurate form. Okay, most accurate is leaving it as a square root. It is not putting it as a decimal. That's having to round it, and rounding is not exact. We want exact. So there's two ways to think of this. 16 times 10, well, 16 is a perfect square. So if I separate those, the square root of 16 times the square root of 10, the square root of 16 is 4, and then we have to leave 10 underneath the radical. The other way to write that is if you do factor 160 in the calculator, it would give you 2 to the 5th power times 5. Okay? And if I write all that out, I've got pairs of 2's that get to come out from underneath the radical. Okay? That's what all this scratch is over here. Okay? So I've got 2 2's that get to come out from underneath, and 2 times 2 is 4. Okay? And 1 2 and 1 5 that have to stay underneath, which is where I get the 10. So I get 4 square roots of 10 as my final answer. For problem number 7 on here, take it one step at a time. Okay? If this were dividing, if this had been a division symbol, you would have wanted to flip this fraction after it. Okay, other classes did have a divide sign there, so you need to know that you would have to flip it after it. Okay, if it's multiplication, then you're just going to work it from there. Move all of your negative exponents to the opposite side and make them positive. So we had a p to the negative 5, so I moved it to the bottom to become p to the positive 5. This p to the positive 5 stayed the same on bottom. P to the negative 4, whoop, it moved to the bottom. Okay, k to the 5 stayed there. Into the negative 3 went to the bottom. But over here on this one, I had some negatives that I had to move to the top. So that's where those numbers in the top came from. This p squared stayed in the bottom. Once I got everything where it needed to go, then I can combine by adding my exponents when I need to add, and then subtract. So this one, when you finish simplifying this one, okay, you end up with nothing left on top and p to the 16n to the 3rd on bottom. Yes, ma'am.
She did not understand how you got the case on the left side, the K3 and K2 from the bottom to the top.
Because it has a okay, the negative exponent means that it goes to the other side of the fraction bar. It's the inverse. Okay. So the negative exponent automatically means it goes to the other side. So if it's negative exponent on bottom, it goes to the top. If it's a negative exponent on top, then they get moved to the bottom.
Is that why the N3 went to the bottom?
Yes.
Okay.
So, and then for problem number 8, it was perimeter. So which means we had to add. When you're adding, if they don't match exactly, you cannot add them. So the only thing you can do is multiply them by 2 and leave them like that. So 2 times 4 is 8. my variables and exponents don't change in this problem. Oops. Sorry, my variables and exponents don't change because all I did was multiply by 2. I'm not doing anything else with my exponents or my variables. Same thing up here at the top. 2 times 1 was 2. I can't change my variables or exponents because I'm not doing anything to them when I multiply it by 2. So they stay the same. And because a to the third, okay, a to the third does not equal a to the 1, I can't do anything to combine them. They're not like terms. They're different. So they're just get added together as 2 separate terms. Okay? So head up, you guys. Just got your head down. Okay? So on number 9, it gives you the area. Okay? You're given the area, and you're given one side. You have to figure out the other side, which means it's a division problem. So 453, x to the 6th, y to the 9th, divided by 151, x squared, y to the 7th. Okay, we're going to simplify those. So 453 divided by 151 is 3. Which is bigger, x or y? Which is bigger, 6 or 2 on my x's? 6. So 6 minus 2 is 4. So my x's stay on top because my 6 was bigger. Okay. Which is bigger, 9 or 7? 9. So my y also stays on top. And 9 minus 7 is what?
2.
Is 2. Right? So that would have been my other side of the rectangle measure in order for my area to be what it is. And then this last one, again, we talked about this one yesterday. And on these, okay, you guys are overthinking these problems. Even if this were a number right here, say this was a 9 and not a p, the 9 would stay the same. Okay, the only thing you are doing is the operation that happens between the exponents because we're leaving it in exponential form. And a power to a power, or exponent to an exponent, we multiply. So what is 1/2 times 1/8? 1/16, right? So this happened to not be a 9, it was actually a p. So it would be p to the 1/16. Now, if you were given p to the 1/2 times p to the 1/8, what would you have to do with those exponents? We add them, right? We multiply them when they're exponents to exponents, but we add them when we're multiplying, right?
Yeah, because you have to go down the list.
You have to go down, yep, down the list. So, okay, so this problem right here, I would have p to the 5/8 power, okay, because I would have to add my fractions to get my answer. Okay, so make sure that I noticed, the only reason I threw this one in there is Get More Math has had some problems like that people were missing. So make sure that you pay attention. If it's multiplying, then you're going to add the exponents. If it's a power to a power, then you're going to multiply the exponents together. Leave the base the same. Okay, whatever the base is, it stays the base. Okay, whether it's a number or a variable, it's not going to change. You're just changing the fraction exponent. So that's the end of recapping that quiz really quick. So it's recorded for you guys. Now go and look at today's notes. Okay. And these should not take that long. If that you guys participate and we get stuff done quickly, then we can. So on this, whether you got, I think everybody in here got a pink one. Oh, no, there were some white ones earlier, but I don't think I have any. They're all the same, either way. Okay, the parent function. Okay, I'm trying to give you some time to work in your get more math, but we got to hurry through these. So the parent function for a quadratic equation is always x squared. Okay, so you will always have an x squared term if it's quadratic. The vertex is this point where they change direction. Remember when we were looking at our tables and determining whether it was quadratic or exponential or whatever, it would start going down. Like I think we had one that, I don't know, and then three, something like that. So it went down and then you could see it change direction and went back up. So that's the vertex right there where it changed direction is the vertex of your function. Okay, so the vertex for your parent function is 0, 0. The minimum looks like it's the same thing, but it's actually not. The minimum is part of your vertex, but it's whatever the y is of your vertex. So the minimum would be y equals 0. Okay. These four things over here, you need to know these. You need to have these memorized, and you need to know that these are all exactly the same thing. If it asks you for the 0, if it asks you for the solution, if it asks you for the root, it is all just asking you for the x-intercepts. Okay, you need to know that all four of those things are synonyms. They're the exact same things. Okay, the STAR test will ask you this question over and over and over again, multiple different ways, and hardly ever will they actually ask you for the x-intercept. They will ask you for the 0, the solution, or the root. Okay, so you need to know all that it's really asking you for is the x-intercept. Okay, guys? So in this case, the x-intercept is x equals 0. Okay, because that's the x-intercept. On this last one here, this y-axis, or the axis of symmetry, okay, that should sound familiar from elementary school, right? You've been being asked to find the line of symmetry of shapes since you were in elementary school. You've been trying to cut them in half so you have exactly the same half on both sides since elementary school. That's all the axis of symmetry is. Okay, we abbreviate that capital A, little o, capital S, is axis of symmetry. And this is a vertical line, so it is x equals, and it's always whatever the x equals in your vertex. Okay, so the parent function isn't really easy to see all the differences of these things. So we've got some other examples on the inside. So flip over to the inside of your booklet here. So what is the vertex going to be for this graph that we have pictured here? Not -1, but it's going to be 1, -9, right? Yep. So we'll label that point. That's the vertex. Okay. The axis of symmetry, okay, again, is this vertical line that goes through that point that cuts it in half. And it's always a line. So it's always x equals whatever the x value is from your vertex. Okay, so these will always be the same number. Is there a minimum on this graph or a maximum on this graph? A minimum. It's like a valley, right? Or a cup. There's a bottom. Okay. So that bottom is called your minimum because it's the lowest point that it can go. And that is always a y equals, and it's always the y equals of whatever your vertex is. Okay, so the vertex tells you your axis of symmetry. It tells you your minimum or maximum. It tells you where the graph's cut in half, where the lowest point, highest point. Okay, so all of those are synonyms for talking about those things. Now, I also told you that these four things are what?
The same.
All the same. Okay, there's a couple of different ways to write these. Okay, so I'm going to show you all of them here. Okay, the zeros. Okay, there we're talking about our x-intercepts, right? So if we write them as coordinates, it would be -2, 0, and 4, 0. Okay? So if you're asked to list them as coordinates, then you would list them like this. Most of the time you will be asked to just list them, which means that you need to use the squiggly braces, okay, and a comma between your numbers. Okay, so the zeros, we would say, is -2, 4. It does not matter which direction you list them in. You can list them as 4, -2, okay, as long as you have both of them in your list. Okay, so squiggly braces, -2, 4. The solutions is also -2, 4. And the x-intercepts are also -2, 4. They're all the same thing. Right? Get More Math does not require the braces because it doesn't want you to use them. It only gives you the parentheses to use. Okay. If you try to use the braces, it might tell you to check your variables or check how you're writing it in there. So just list the numbers with a comma between them for the Get More Math questions. Okay. The y-intercept. What does the y-intercept mean? Actually, so label these. So these are the zeros, solutions, roots, x-intercepts. Okay. That's the same thing as that one over there. Right? They're all the same. You can list them over here on this other side. I just don't have room on my screen to do it because I'm writing too big. Y-intercepts, or the y-intercept, is what? -8. Okay. So that's the y-intercept. So y equals -8 or just -8. Okay. In Get More Math, it just wants you to say -8 because it's not a line. Okay. So I'm going to just put -8 on there. The axis of symmetry has to be an equation. It has to be x equals because it's a line that we're talking about. The minimum and the y-intercept may just need to be the number. It's not going to ask you for the equation. The domain. Does it stop going left or right? No. Okay, like we talked about before, all real numbers for the domain. The only time it will not be all real numbers is if it's a word problem. Okay, because it doesn't make sense to have negative people, seats, tickets, time, all of that stuff. Okay, that you're counting. The only thing that makes sense to be negative is money sometimes. Okay. The range. My range is always tied to my minimum or maximum point. It's always my y. So are my y values going up or down from -9? up, which means all my y values are greater than or equal to -9. It can be -9 because that's actually my minimum point. It does touch -9. So y is greater than or equal to -9. Okay. So now I'm going to give you about 2 minutes at most, and I'm going to come around and look and see how you're doing. But I want you to try to answer the blanks on the other side really quick on your own, and then we'll see how you do on that in just a moment. Okay. I'm not going to walk around just because of the lack of time that we have. So, but there are the answers, so you can check, okay, your answers and get them labeled. Okay, so your vertex should be 1, 4. It is a coordinate. You do have to have parentheses around that. Okay, the axis of symmetry is x equals 1. It has to be written x equals 1. Okay, so you may need to put an asterisk next to these. These have to be formatted like that. They have to be a coordinate, and that one has to be a line. Has to be a point, has to be a line. Okay, maximum is 4 because it opens downward, so it's like a mountain. It's got a high point on it. The zeros, roots, solutions, x-intercepts, all the same thing. -1, 3. Your y-intercept is 3. Domain is all real numbers, and your range is y is less than or equal to 4 because 4 is the highest or the biggest it can be. Okay. Okay. So, like I said, in your Get More Math, what we saw in second period was formatting. So if you put a space after the comma or don't put one, it might flag you with a window or whatever. So formatting sometimes. But those of you that have been assigned to my homeroom, you are not assigned to it today, but you are more than welcome to still come, but you need to go check in with your homeroom teacher if that's the case and get a note saying that they know that you're here. Okay? And then you're more than welcome to come back.